Hello, and welcome to this introduction guide to the Atomic Agents framework. The main goal is to eliminate any unnecessary complexity while building powerful AI applications and maximize developer experience. The framework aims to provide a high level of modularity, predictability, extensibility, and control, and just really as much ownership as possible. Some of the key features of the framework are a really high level of consistency through extensive use of just an IPO model throughout, which means each agent has an input schema. Each agent has a way of processing that input schema and then giving you back an output in a very specific schema. There's also the Atomic Assembler CLI, which allows you to download tools and modify them as you see fit, as opposed to installing them as dependencies and having them be a part of the core library where you can't modify them. And everything within the framework aims to be easily swappable, since everything uses the same IPO model, the same type of input schemas, output schemas, run methods. So just as a quick example of the CLI here, let's assume we have a new empty poetry project. The first thing we will probably want to do is install Atomic Agents. And once Atomic Agents has been installed, you can simply run the CLI by typing atomic. This will present you with a menu, which you can navigate with your arrow keys. You can press enter to go to download tools, where you will see an overview of our tools. Currently it's not a whole lot, but already you can do a whole lot of things with just those tools, and it's also really easy to build your own tools. So let's have a look at what a tool includes. Let's go to, for example, the YouTube transcript scraper. And if we now press I, you can basically see the README of the tool. And inside of this README, it says what you will need. So of course that includes Atomic Agents, Pydantic, Google API, Python client, YouTube transcript API. There's some instructions such as what you'll need. You'll need an API key. There's some help on how to obtain an API key. So again, this is all in the spirit of maximizing developer friendliness. And if you are to create your own tools and you want to create a pull request with your own tool so that it ends up in the Atomic Agents framework, this is also what you will need to provide. So the input schema is explained, the output schema is explained, some example usage, how to contribute, and license. So we can now press escape to go back. And let's say I want to get this YouTube transcript scraper. So I can select the item with enter, and now it's going to ask me where I want to download it. In my case, I will use my left and right arrow key to navigate now. I will go inside of the CLI demo folder. It's still empty, as you can see. I can press N to create a new folder, and I will name it, let's say, Tools. And I can now select the Tools folder. It will ask me for confirmation. I press Y, and the tool has now been copied into the Tools folder. So if you now look at what's inside the Tools folder, we have Tools, YouTube transcript scraper, and inside of that folder we have a tool and a tests folder. And we have a README. The README is basically what we just saw in the CLI. The tool itself has the actual tool, which you now have full control over. The tool, just like our agents, has an input schema, output schema, or multiple output schemas in this case, since it's composed out of multiple. We have a YouTube transcript tool config, and we have the tool itself with the run method, which is the main entry point for every tool, and some helper methods, some example usage. And here we have tests, which should provide 100% test coverage for our tool. Of course, we still need to install the dependencies as explained in the README. But once we would have done this, we can run the tool, and yeah, that's basically how you use the CLI. So how does Atomic Agents compare to CrewAI and AutoGen? While CrewAI and AutoGen are frameworks focused on having agents that talk to each other and come to some kind of conclusion together, Atomic Agents really focuses more on giving you complete control over the flow and over how that will happen. While it's certainly possible to completely autonomously have agents talk to each other, usually what you will be building with Atomic Agents looks more like an agentic pipeline. And if you look at LangChain versus Atomic Agents, well, LangChain just has a ton of unnecessary abstractions, a high and also a necessary learning curve, and there are a bunch of tools, most of which you will never use and that do nothing else but introduce a lot of extra dependencies into your project, and you don't really have any ownership over the code of any of these tools. An agent really consists of several important components, one of which is, of course, the system prompt. Then you have the aforementioned input and output schemas, which are validated through Pydantic. We have the ability to include context providers, which allow you to inject context or inject information at runtime. And of course, we have memory. Creating an agent is really simple. You just use instructor with whatever provider you want to use. That could be OpenAI, it could be Grok, it could be Anthropic, it could be a local model with Ollama or whatever you want. You could even have one agent running OpenAI's GPT-4o Mini, whereas maybe another agent is using Grok. And here you see a system prompt being constructed, very much inspired by the way it's done in Daniel Miesler's Fabric tool. You have your background, which defines the personality of the assistant. You have the steps which it has to do to get to the output. And you have your output instructions, which kind of define what your output should look like or how it should be formatted. And then, of course, you can customize your input and your output schema. Important to note is that a schema must always inherit from the base I/O schema, and docstrings are enforced. The reason for this is that docstrings actually end up in the system prompt, which saves you a ton of prompt engineering. Well, technically it is prompt engineering, but it doesn't feel like it. Plus, as a bonus, of course, if you're using any documentation tool will also extract docstrings and be able to build some nice documentation out of this as well. So while you are just doing your thing as a developer and building your documentation, you're also doing your prompt engineering. And as mentioned before, you have context providers, which allow you to inject real-time data into your prompts. What this looks like is you have a class. Your class extends from the system prompt context provider base, and it has a single method. Of course, it can have more methods, but one is required, which is getInfo. And getInfo returns a string, and that string is the one that ends up in your system prompt. Here you see an example of it being used to format a date and signify what day it is. This could be handy, for example, if you have an agent that needs to fetch some news and you want to make sure it's not old news. And here you see it being used to format some search results for an agent. As mentioned before, there's also the Atomic Assembler CLI, which allows you to download tools and take full control over them. If you need to change it in a way that's completely incompatible with what's currently in the repository, then you go ahead and you do that. It's your codebase. As I alluded to before, agents and tools have the same building blocks. Both agents and tools have input schemas, they have output schemas, which are basically pedantic models. They have a run method, which serves as the main execution point. They have a configuration, which actually also is a pedantic model. This highly consistent pattern makes the framework highly predictable and extremely maintainable and developer-friendly. This also makes it easy to just chain everything together, make sure everything is type safe, and as I said before, makes everything highly predictable. So chaining agents and tools together, I mentioned this a few times. What does that mean? Basically, it just means that since the input schema is a pedantic model, and since the output schema is a pedantic model, you can just have the output schema of an agent be the input schema to another agent, or be the input schema to a tool. So here you can see a snippet for a deep research pipeline that I'm creating as an example for the codebase. As you can see, I like to keep my agents in separate files. I have my tools here. These tools come from the Atomic Forge and are downloaded through the Atomic Assembler CLI. I have defined my own input schema with information that will come from the user. But important to note here is that the output schema of this particular agent is actually the input schema to the search tool. Now if we go look at this input schema, you will be able to see that our agent will actually output a list of queries and a category. By default, the category will be general. It can also be news or social media. And so by specifying the input schema of the search tool as the output schema of the agent, we make sure that given this instruction and given the number of queries to generate, we will generate a list of queries in a given category. In fact, if we just really quickly test that out, we can see here that it generates queries, which is a list, and the category here is news, as expected. Notice here how one of the queries says AI technology advancements 2023. This can of course easily be mitigated with our context provider, which is not connected here to the agent, because it's just an isolated example. Or of course you could add it somewhere in the background or output instructions, but the recommended way is the context provider. All of this just contributes to increasing the modularity and the swappability of every component. For example, let's say you have an agent that makes an appointment in a Google Calendar, but now you need to make it work with some different type of calendar system. A different type of calendar system will probably have a different API, which means a different pedantic model. In this case, you will just swap out the output schema of the agent, and it will just automatically adapt to your new API. So in summary, Atomic Agents is a framework that emphasizes modularity, developer experience, control, ownership, clarity, all of that good stuff that we love as experienced developers. And unlike other agentic frameworks, Atomic Agents really puts the developer first, puts the developer in full control over every part of the flow, and it ensures that AI remains predictable and transparent. And so yeah, that's it really. I really hope you will enjoy working with Atomic Agents. Keep an eye on the YouTube channel for more videos and tutorials and guides and all that good stuff. Be sure to give a like, subscribe, give a star on GitHub, and yeah, enjoy. Bye.